This is an example of a rational expression. To simplify a rational expression, we can use the knowledge that we have of factoring. Notice the different parts we have. We have this polynomial here, a quadratic polynomial, because it has that squared. Down here we have a difference of perfect squares. This is not a quadratic, and we'll talk about that in a moment, and another polynomial. To simplify this, let's just factor each part, and I'll begin with the numerator from this term. So this breaks into a product of two binomials. I'm going to put my x and my x. Are the signs going to be the same or different? Because that's a plus sign, these have to be the same. Which the same? I see they're both going to be pluses. So I put a plus and a plus. What are two numbers that multiply together to be 6 and add up to be 5? I think that'll be a 3 and a 2, just like that. Now let's see about what can we factor this bottom term into. This is a difference of perfect squares that we learned about in the last video. And so you should know the pattern for that. We have an x and an x. The signs have to be different. What number can I multiply by itself to get a 4? Yes, that's right. We can multiply a 2 times a 2. And this one has been factored. I'm going to bring down the multiplication sign. Let's factor this part. Do you see how there is no squared in this one? When there is no squared, that means we cannot break it into two binomials. But we can still look for a greatest common factor. Is there any number I can pull out of a 5x and also out of a 10? The biggest number like that is a 5. So I'm pulling out a 5. That's my greatest common factor. What's left on the inside? 5 times what gives me 5x? Definitely have to put an x there because 5 times x gives me 5x. I bring down the plus sign. 5 times what gives me 10? That has to be a 2. And this one has been factored. Let's take a look at the final term, this denominator. That's going to break into two binomials. So I'm pulling out two binomials. We have an x and an x. What should the signs be? Well, it looks like the signs have to be the same because it's a plus sign, and they have to be both pluses because that term is a positive. So I put a plus and a plus. What are two numbers that multiply together to be 12 and add up to be 7? I believe that is going to be a 3 and a 4. Now we have completely factored everything. Now we need to look to see if there's any common factors from the top and the bottom. Let's see, is there any other x plus 3s? Yes, there's an x plus 3 there and an x plus 3 there, so those cancel out. Is there any other x plus 2s? Yes, there's an x plus 2 here, there's also an x plus 2 there, and so these ones cancel out. Is there anything else? No, it doesn't look like it, so we can bring it all together now. Let's bring together what's left on top. What was left on top was our 5 times the quantity x plus 2 over what was left on the bottom. On the bottom, it looks like we have the quantity x minus 2 times the quantity x plus 4. This can't be simplified anymore, and so this is the final answer.